In this video, we're going to look at the Excel portion of the example that we're working with, which is GMAT preparation programs and the college from which students graduated. So here we are setting it up slightly differently from the previous video. So we have factor A, which is GMAT preparation programs, as rows, a 3-hour program, 1-day program, and 10-week program, and factor B, the college, as columns. So we have the means here, and here is the data, and we have A is equal to 3, so that is the number of levels of factor A, 3-hour program, 1-day program, and 10-week program. Now B is equal to 3 as well. That's our college. Then there are 3 different colleges, and for each combination we have 2 replications. We have 2 students from business school assigned to 3-hour program, 2 students from business school assigned to 1-day, 2 students from business school to 10-week program, and so on. So the total number of observations here, so that is n sub t, is the product of those 3 numbers, A times B times R. And we're going to generate the output using data analysis command. So go to data analysis. Now we have to select ANOVA 2-factor with replications. So now the data set should include the labels. Okay, must always include the labels in this case. It's not an option, you have to include it. Then the rows per sample, so that's your replication R. So how many observations are there in each sample from the combination of 1 level of factor A and 1 level of factor B. Let's put the output in A24, and that generates the output. So we have summary table first for each sample. Okay. Here the factor B and then the factor A. So each combination gives you the information for each sample. Then if you look at the rows, okay, that's your mean for 3-hour program. That's the mean for 1-day program. And that's the mean for a 10-week program. Similarly, if you look at each column, the columns totals are summarized right here. So the first one is College of Business, College of Engineering, and Arts and Sciences. Okay. The analysis of variance table is the second part of the output. Okay. Here we have the first one, sample, is the rows. Okay. Rows for us is factor A, so that is program. Columns represent factor B, which is college. And then we have interaction, and within is the error, and we have the corresponding F values and the P values for the 3 hypotheses that we have to test. The F critical is F table, we don't have to worry about that. We'll set a P value as a percentage. So now we have 3 hypotheses to test. The first hypothesis is whether the row means, okay, mu1 dot is equal to mu2 dot is equal to mu3 dot. And the alternative is that at least one mean is different. And the conclusion here for this test, okay, since p-value is greater than 5%, we cannot reject the null hypothesis. Factor B is mu dot 1 College of Business equal to mu dot 2 College of Engineering equal to mu dot 3, which is Arts and Sciences, against the alternative that not all means are equal. Now here our p-value is less than 5%, so we reject the null hypothesis. The third hypothesis is interaction effect AB is significant or not, and the hypothesis should be stated in this fashion. Null hypothesis is that there is no interaction effect. Alternative hypothesis is there is interaction effect. Now we check the p-value. Once again, p-value is 35% larger than 5%, so we cannot reject the null hypothesis. So the conclusion is do not reject H sub O. We can further analyze the interaction effect by plotting the means of different levels of factor A and different levels of factor B. So we look at the graphing in the next video.